All right, let's jump right into this explainer. Today, we're looking at a massive environmental challenge and the frankly brilliant ways heavy-duty machinery and invisible digital architecture are teaming up to solve it. We usually just toss things in a bin and forget about them, right? But we're zooming in on the hardcore logistics of industrial wood waste. We're going to see how specialized fleets and data are literally transforming garbage into the bedrock of a circular bioeconomy.
10. That's a pretty sobering number, because 10 years is the absolute maximum landfill capacity Ontario has left if we keep dumping at current rates. According to baseline reports, the clock is ticking, and it's ticking fast. In just a decade, the province simply runs out of approved dirt to bury its trash. So that gives us a super rigid, unforgiving timeline to totally rethink how we handle the leftovers of our economy.
When you're actually standing next to one of these mountains of baled waste, the sheer physical scale is just staggering. I mean, we are generating between 12 to 15 million tons of non-hazardous waste every single year in Ontario alone. To put that into perspective, we are quite literally running out of physical space. It's a looming capacity cliff, and we are driving straight toward it. So we desperately need to rethink how industrial, commercial, and institutional waste, or IC&I for short, is handled before we go over that cliff. The 2021 Auditor General put it pretty starkly. They pointed out that a lack of government action means we're going to be facing hard questions about where all this waste goes. Avoiding this reality? Yeah, not an option anymore. The financial and environmental costs of just doing nothing are massive, and the solution absolutely requires the business sector to step up. Here's exactly how we're going to unpack this explainer today. First, Ontario's landfill capacity cliff. Second, the transfer station trap. Third, 144-yard walking floors. Fourth, hubs, spokes, and FIFO. And finally, the EDI 204 backbone. All right, Section 1, Ontario's landfill capacity cliff. When most of us think about recycling, we immediately picture the blue bin at the end of the driveway, right? But residential waste actually only makes up about 30 to 40% of the total pie. The real heavyweight here is the IC&I sector, generating a massive 60 to 70%. We're talking factories, construction sites, giant retail centers, and a massive, massive portion of that is wood. Everything from construction debris to endless stacks of shipping pallets. Residential gets the spotlight, but IC&I is the real elephant in the room.
Moving on to Section 2, the transfer station trap.
Now, this is where things get a bit crazy. A recent audit uncovered a frankly shocking statistic. 66% of transfer stations accept separated industrial recyclables, only to turn around and funnel them directly into landfills or energy from waste incinerators. So they're acting more like a trap than a diversion point. Companies are actually paying a premium to recycle their wood, but thanks to logistical bottlenecks, contamination, or just bad economics, 2/3 of the time, that material gets buried anyway.
So why does this trap even exist? Well, it actually comes down to the physics of wood waste. Wood is incredibly bulky but relatively light. Mixed wood waste has a density of only about 174 kilograms per cubic meter. Because it's so light and fluffy, standard garbage trucks will what they call cube out. Basically, they fill up all the physical space inside the truck long before they weigh out or hit their legal weight limits on the road. So you end up paying huge fees to transport a whole lot of empty air. It drives transport costs so insanely high that transfer stations find it cheaper to just dump the wood rather than properly process it. Which brings us to Section 3, 144-yard walking floors.
This is exactly where heavy engineering steps in to save the day. Fleet logistics operators like 905 Wood deploy these absolute behemoths, 144-yard walking floor trailers. These giants boast an internal volume of over 108 cubic meters, meaning they can haul nearly 19 metric tons of loose wood waste in a single run. But the real game changer? The walking floor itself. Instead of lifting the whole trailer bed up into the air to dump it like a standard tipper truck, these trailers use hydraulic slats on the floor to literally walk or push the material out horizontally. Now, why does that matter so much? Well, dry biomass feedstock needs to stay dry. Weather ruins it, so it has to be stored indoors. Walking floors allow these massive trucks to pull right inside tight storage halls and biorefineries with low ceilings and unload safely without tipping over. This physical brawn completely bypasses that transfer station trap we just talked about, enabling a direct diversion pass right to the end users.
Next up, Section 4, hubs, spokes, and FIFO. Okay, so when these massive trucks deliver all this wood to regional biohubs, you can't just dump it in a random pile and hope for the best. The system relies on strict inventory logic, specifically FIFO, or first in, first out. This scientific methodology is an absolute must because wet wood naturally degrades. If older wood gets buried at the bottom of a pile, it basically starts composting and self-heating. And if it does that, it completely destroys its calorific value, making it absolutely useless as a biocarbon feedstock. So rigidly enforcing FIFO to manage this degradation is absolutely crucial.
And finally, Section 5, the EDI 204 backbone.
Now, how do you manage all this physical scale without total chaos? Enter the invisible digital nervous system, electronic data interchange, specifically the EDI X12204 Motor Carrier Load Tender Standard. This is the precise digital code that lets a waste generator instantly offer a load to a carrier. It's perfectly structured. It cascades from the top-level ISA interchange control header, right through the GS functional group, down to the ST transaction set header, and then wraps up neatly with the SE trailer. This rigid, bulletproof data architecture flawlessly routes every single payload. It ensures the exact right-size truck is matched to the specific volume of wood, maintaining a rock-solid chain of custody from a muddy construction site all the way to the biorefinery.
When you take that super robust EDI 204 backbone and turbocharge it with modern AI, things get hyper-efficient. We're talking smart sensors installed right inside the dumpsters, pinging capacity levels in real time. So instead of a driver running a fixed route just to check on bins that might only be half full, AI algorithms dynamically schedule the pickups only when a bin is genuinely at max capacity. This precise load estimation guarantees those massive 144-yard walking floors are fully utilized every single trip. It cuts out unnecessary drives, slashes fuel consumption, and massively lowers the transport carbon footprint. It's a total win-win.
So as we stare down this very real 10-year limit on Ontario's landfill space, it really kind of changes your perspective, doesn't it? The next time you're on the highway and one of these massive transport trucks blows past you, ask yourself, is that just another garbage hauler driving to a dead-end landfill? Or is it a highly engineered, data-driven node literally powering the beginning of a circular bioeconomy? The density problem of wood waste is a giant puzzle for sure. But as we've explored today, when you combine brilliant digital architecture with some serious physical machinery, we actually have a very real, very actionable pathway out of this crisis.